I'm going to look at 3 shaded area problems that we looked at in class today. For all 3 of the problems, I'm looking at a complex figure, a figure that's made up of more than one type of polygon. So instead of just being a square or just being a triangle or just being a trapezoid, it's some combination of these different figures. In number 1, I've got a series of rectangles that are forming that pentomino type figure, that Z shape. In number 2, I have a square with a cross shaded out in the middle. And in number 4, I've got a circle with a square that has been inscribed in the middle. So some combinations of shapes. For all of these figures, I'm either going to be adding up a bunch of areas or taking a couple of areas and subtracting them from each other. And we'll talk a little bit about whether I'm adding or subtracting in each case. In number 1, the problem has already been divided up for me into 3 separate rectangles. I'm going to use the rectangle area formula, area equals the base times the height. And my top rectangle, this rectangle right here, is 20 by 5 inches. So I'm going to go 20 times 5 and I'll get 100. So this is 100 inches. My next rectangle, well, from the top down to the bottom, let me erase this top rectangle here. From the top all the way down to the bottom, that's 12. To here is 5, so that must mean that what's left over is 7. 5 and then 7. And I'm going to use the same reasoning to figure out how much this is. All the way across is 20. From here to here is 10, which means from the right side to the left side of that middle rectangle is also going to be 10. And now I'm looking at 7 times 10, or 70. So my middle rectangle's area is 70 inches squared. And then I'm going to look at the bottom rectangle, which is 16 by 6. So 16 times 6. $96. And then I'm going to add all of those together, all of those areas together. The first rectangle, the second rectangle, and the third rectangle's area. All together, how much is that? So 100 plus 70 plus 96, 266 altogether. And I need to include units in my answer, so that'll be inches squared. 266 inches squared. Number 2, there are several ways I can go about this problem here. I could figure out the area of that whole square, right? It's a square. It's the same both length and width. And then subtract 4 of the little squares, right? 1, 2, 3, 4. By subtracting, I'm basically cutting away those white parts and leaving the cross behind. I could also divide the cross up into 4 parts. So 5 parts. 1, 2, 3, 4, 5. Figure out what each of those areas are and then add them together. But I think I'm going to do this first method. That's what we chose to do in class today. I'm going to find the area of the entire square. So my length times my width, or since it's a square, I could say side squared. And my length is 5 plus 4 plus another 5. So that would be 14. So that'll be 14 by 14, or 14 squared. And each of these little squares are 5 by 5. So 4 4 times 5 squared. I've got 4 of those. 14 squared is 196. 5 squared is 25, and 25 times 4 is 100, and 196 minus 100 is 96. And then I need some units. They are meters, so my answer is 96 meters squared. There's 96 square, or not, there are 96 square meters in this cross. And the last one I'm going to do with you on this video is number 4. And in number 4, I've got a square that is inscribed, drawn inside a circle. And I want to find out the space of the circle that is not covered by that square. In a sense, I'm finding the area of the square, and I'm mathematically cutting out, I'm subtracting the area, I'm finding the area of the circle, and then I am mathematically cutting out the area of the square. So the two formulas I'm going to need are pi r squared and side squared. So the r in the pi r squared is the radius, and the radius is that piece right here, half of that, there's the diameter, and I don't have that value, but what I do have is a right triangle that's 5 by 5 on a side. So I'm going to start off by figuring out what the diameter is using Pythagorean theorem. A squared plus b squared equals c squared. The two legs squared added together will give me my hypotenuse. In this case, my diameter squared. So one leg is 5 squared. The other leg is also 5 squared. I've plugged both of those into the formula. 5 squared is 25. The other 5 squared is 25. If I add those together, I'll get 50. And 50 is equal to c squared, or my hypotenuse squared. Take the square root of that, and I will have my hypotenuse. Now, I don't want that whole hypotenuse. I just want half of it. I just want this part right here. So that's going to be 1/2 of 50. 1/2 of the square root of 50. That's really what I want. And because I'm going to be doing other things with that amount, I'm not going to put it into the calculator and get a rounded amount yet. I'm going to wait until the very end to pop things into the calculator, and then I will estimate or make a rounded answer. But I don't want to round too far in the beginning because, as we've talked about many times, that rounded answer used again will compound the error that you create by rounding. So I'm going to leave 1/2 radical 50 as part of my answer. So let's see, pi, or part of my problem for right now, pi times 1/2 radical 50 squared. So there's my circle. Now let's see, my side, or my square, has 5 on each side, so that's going to be 5 squared, so minus 5 squared. Right now I'm looking at the square here. Now I'm ready to put that into the calculator. Maybe I'll make this 25 first of all. So pi times 1/2 radical 50 squared minus 25. All right, I'm going to be using a lot of parentheses here just to make sure that the calculator is following order of operation. Pi times parentheses 0.5, that's a half, times parentheses the square root of 50, close my parentheses. I want to square that amount, and go ahead and multiply that by pi, subtract 25, And I've got 53.5398. 53.5398. And I don't believe there are any suggestions about where to round to, so let's round to the nearest tenth, 53.5. And my units are inches to begin with, so I'm finding area, I'm going to use inches squared.